Welcome everyone to Kellenberg's first coding session. If you're here, that means you're probably interested in coding. Good for you. After the intro video, this is the program that you should have downloaded. It's called VexCode Pro V5. As you can see, I have two recent projects, but you will have nothing here. But I wanted to introduce you to what coding is all about before we actually get into the technicality of coding. This first slide, I want to thank my computer teacher, Mr. Campbell, for creating this for my computer class, but I wanted to share it with you guys because it really details and defines what coding is all about. So I wanted to start off with the makings of a program. First is a variable. What is a variable? Well, it is a name storage location that can hold various values. Those values have types, and those types are variables that can store numbers, letters, and Boolean, whether it's true or false. And those types are integers, int, floats, strings, bools, which is Boolean. That's what we're going to be looking at. There are inputs in every code. So programs get inputs from the end user, files, database systems, web services, and etc. For example, a program may ask the user his or her name, and the user would provide the input by typing his or her name. And the input would typically be stored in a variable, usually a string. A string is something that is in quotations. Computation. Computations are performed in math. So there are addition, subtraction, multiplication, division, exponents, modulus, which is remainders, and floor. Comparisons are programs that compare items and evaluate whether they are equal to, less than or equal to, greater than or equal to, or not equal to. And this goes straight into the logic aspect of it. It's Boolean code. Whether something is true or false, depending on what you state in your code, will then return either a true or false statement. There's nothing in between. Then you have loops, which are things that need to be repeated. And then basically, instead of having a long code, you have a short code that loops again and again if it's the same thing you want to happen. These use for statements as well as while statements. Programs will use conditions to determine sets of instructions to execute. So a program determining a set of instructions to execute based on the evaluation of a condition. So these are if statements, if else statements, if else if statements, and so on and so forth. Functions. We use functions in a program to encapsulate a single task that would typically take many instructions. So a function would be like printing to a screen or reading and writing to files. And then of course the last thing is the output, what the program produces. Displays on a screen, whether it be the brain of your robot, written to a file if you're making an HTML file on a web server, or printed on a printer, so if you code to print on a printer. These are the basics to coding in general. Now I want to introduce you to Vex C++. I found this on the web from a teacher who teaches to her class what Vex Robotics is, and I'm using her slides from page 14 and on. So this is what you'll see when you open up Vex code. When you open a new project, you want to name it. Usually, you name it with no spaces. Every time there's a new word, you capitalize the first letter. And it can be only less than 21 characters. I like to name my projects based off of the year of competition, if it's a competition project, or what type of test I am doing. In the editor, this is all that you will be seeing in the next couple of slides. The project name, the project slot, you can have up to 8 slots. This is the device info, so when you plug in your robot to the computer, the robot brain, you will see all the device info, the brain name, the team name, the brain ID, VexOS, and firmware. You want to make sure that the firmware is up to date, so keep an eye out for that in case Vex decides to update their firmware. Compile and download is this next one. Play to your robot so that you can see how the robot reacts to your code, and then stop if something is wrong before it completes its code. And split editor, I don't really use that, so it's not really necessary. The editor also helps with errors. Here it says suggested correction, so sometimes it will hint at what you should need to fix your problem. Clicking on a light bulb would give you a suggested correction, which is what they're getting at here on the left. Highlights errors, so when something is incorrect, like there's a space here, it will highlight it. Problems can also appear on your console, which appears at the bottom of your screen. You can open and close your console by clicking this arrow. The output tells you how it's saved, where it's saved to, and whether it works. The problem section gives you the error info, such as the description and location. You, when opening a new file, will not actually have everything given to you. That's where you need a competition template or whatever template you're using for the time. The most common is a competition template, which I will show you later in this video. What they're showing here is Intel main is where the program starts. Of course, there's more above it, but that's given definitions based off of the namespace, which you will read in this month's assignment. The program ends from wherever the program starts. So Intel main is just one program. You can have multiple programs in your code. They are defined in between these curly brackets. We already talked about downloading and running, but this is what it would look like on your V5 brain, and this is what it looks like when it's already started. Coding, syntax, and notes. So punctuation is very important. In tonight's assignment, you will have a link to a cheat sheet that will give you a much broader understanding of what C++ is about, but this is a great rundown as to what the most common syntax is used in VEX code. Parentheses back to back are used for the arguments set to the command. A semicolon marks the end of a command. Double quotation marks surrounds the characters that will show up on the screen when using that function. Double forward slashes are for a one-line comment. A forward slash asterisk to an asterisk forward slash are for multi-line comments. This function is defined within a string that shows on the screen, which is the double quotation marks, and all commands and variables are case sensitive. So now I want to explain this month's assignment. I have created a Google Docs that has questions that you are to answer after you click this link and read the first 4 sections under the C++ tutorial. You're going to download this to Notability, answer the questions, and then send it back to me in an email. There are 9 questions, and also I provide links that may help you if you're more interested in learning about C++ outside of VEX code. I want to quickly hint at the last question. It is a question that asks you to write a code yourself based off of what you read to see if you understand. And you're going to click this link, c++.shell, and I already plugged in what function I gave you, and your assignment is to finish the code and get the output that I ask for. So it would be whether num1 equals num2 and what is num1 times num2. When you write in your code, you want to click run, and in execution it will give you an answer. What I want to end off today's class with is getting to know the competition template for VEX Robotics competitions. So in order to find it, you want to click File, and you're going to open Examples. Now you're going to scroll down here to Competition Template and click Next. I would name it Competition Test, but when the competition comes around, you want to name it how it is. I'm going to lower the console so you can see all of this. It's going to immediately give you all of the templates necessary to start coding for a robot design. So you already have include vex.h, you have already using namespace vex, you have plenty of things, pre-autonomous, void autonomous. I'll explain this all in the next video. On this left side, you're actually in src main C++. So this is the main code, but the robot configuration here is where you're actually going to be automatically putting in keybinds to recognize the controller to the robot. So in order to do that, we go up to motors and add a device. This is like a motor symbol. So first you want to add a controller, then you want to add motors. So I want to add a 4-motor drivetrain. I'm going to add the first 4 slots for motors. I have no gyros on them. So you can keep this all the same. The gear ratio will change depending on what you have in your drivetrain, but the builders will actually let you know what their gear ratio is. I usually have a 1:5, and the motors itself is always at 200 RPM. This is the way the robot is facing, so you're going to click Done. And that already, as you can see in robot config, will tell the controller what motors, left motor A, left motor B. You can look further into it. I'm not going to really explain it because it does it automatically. And you can also go to VEX forums if you have any questions further about that. So now you can click on this. These are the axis knobs on the controller. and you can figure out which way you want to do it. I want to do a tank drive, so left is going to be the left 2 motors, right is going to be the right 2 motors. If you want to, let's say, have an arm, so we're doing a clawbot, you add another motor, let's say to 5, and you name your motor. So I'm going to name it the claw arm. How is your motor going to spin? Forward to the left, reverse to the right. That's normal. If you want it to be in reverse, it's going to be forward to the right, left and reverse. I'm going to keep it normal. Now you can go back into your controller and say, what do you want? I want right button to be the claw arm, where the right front is forward and R2 is reverse. So that's how you assign your ports to the motors on the controller. Not only do you have a reading assignment, but I want you to send me a screenshot of you doing kind of the same thing, assembling a drivetrain. It can be either 2 or 4 motors, and try and add an extra motor or 2 for whatever you see fit. That's basically getting started in VEX Code, and in next class, I'm going to be going over how to just simply start so that when you press these buttons, your robot will actually start moving in driver control. Thank you all so much for watching, and I look forward to seeing all of your assignments.